I'm going to summarize the kinetic molecular theory into 6 points. But before we do that, let's revise two terms that will help us understand the kinetic molecular theory better. These two terms are an atom and a molecule. So once we've revised these two terms, we will be in a much better position to understand the kinetic molecular theory. What is an atom and what is a molecule? An atom is a building block of matter. So an atom can be described as a building block of matter. Like a brick is a building block of a house. So one brick would be the building block of this entire house. An atom is the building block of matter. Everything that you see around you that takes up space and has weight is made up of atoms. There are different kinds of atoms depending on the number of protons, electrons, or neutrons inside that atom. So we can have a green atom. This is just for demonstration, as well as a blue atom. So the difference between these two atoms would just be the number of electrons and protons and neutrons that each of these atoms have. So this is why we say that atoms are building blocks of matter, right? What is then a molecule? If we talk about a molecule, what actually are we talking about? What is the difference between a molecule and an atom? So what is a molecule? A molecule, on the other hand, can be described as a group of two or more atoms. So a group of two or more atoms. So for examples, if we have this blue atom and it is chemically bonded to another atom, so now we have a group of two atoms chemically bonded together. We call that a molecule. So even the different atoms can chemically bond to each other. So now we have these two green atoms chemically bonded to one another, forming a molecule. Or we have a blue atom bonded to a green atom. They are chemically bonded, meaning that they are can be regarded as molecules. So molecules are groups of two or more atoms chemically bonded together. So now we are in a position to understand what is an atom, what is a molecule. So we have molecules. We can also have atoms. Why was that important for us to define those two terms? Later in the video, I will refer a lot to a particle. So each time I say a particle, which I will represent with this red circle, every time I say a particle, I can either be referring to a molecule or an atom. So every time I say a particle, you must think I'm either referring to a molecule or an atom. So I'm either referring to a group of atoms bonded together or just a building block of matter. I hope that is clear. All matter is composed of small particles. Everything that you see around you that takes up space and has weight is made of small particles. Let's imagine that this red circle represents a particle and that this red block represents matter, in a sense that it takes up space and has a weight or has a mass. We can then imagine that this red block is made up of these small red particles. So these particles are the building blocks of this block. So all matter is composed of small particles. That is the first point of the kinetic molecular theory. All matter consists of small particles. There's something interesting about these particles, and that is they are always in constant motion. They are always moving. In solids, they may be vibrating in their fixed position, but that is still a sort of emotion. So they are in constant motion. In liquids, and especially in gases, these particles may move or are in constant random motion. So one particle may be moving in that direction, right? And then another one, perhaps it moves in this direction just randomly. Perhaps another particle then moves in this direction. You are starting to see the picture. So these particles, so the second point of the kinetic molecular theory is that particles are always in constant motion. Between these particles are forces of attraction. These forces of attraction keeps the particles together. So for example, we can think about two particles, this one and this one. And between these two particles, there are forces of attraction. That is, they are attracted to each other. So this particle will be attracted to this one to this one, and this one in turn will also be attracted to the other one. So these particles, between them, there are forces of attraction, and that is the third point of the kinetic molecular theory. There are forces of attraction between the particles. Because these particles are in constant motion, they will start to collide with each other or with the container they are in and exert pressure. So imagine we have these two particles in this container. They will start to, and they're moving in random motion, right? At some point, they will collide with each other, or even collide with the walls of the container. And as they do that, they exert pressure. So that is the fourth point of the kinetic molecular theory. Particles collide with the sides of the container or with each other and exert pressure. Because the particles are moving, they have kinetic energy. The faster the motion of the particles, the higher the kinetic energy, and the hotter the particles become. For example, think of water particles at 100 degrees. This is when water starts boiling. So think of it. Think of these particles, water particles at 100 degrees. For water particles at 100 degrees Celsius, it means this is very high temperature. So the particles start moving really fast. This is why they even start boiling, meaning that their kinetic energy is very high. So the fifth point of the kinetic molecular theory is the temperature of a substance is a measure of the average kinetic energy of the particles. So kinetic temperature is just a measure of kinetic energy. When the kinetic energy of these particles changes, the phase of the substance changes. For example, a substance might change from the solid phase to the liquid phase, or from the liquid phase to the gas phase, because of a change in energy, right? So let's think of water, for example. Remember, we said that temperature is just a measure of the average kinetic energy. So if we take water, let's take water at 0 degrees Celsius and water at 100 degrees Celsius and somewhere in the middle. So water at 0 degrees Celsius is ice, which is let me put it here. It's ice, which is in its solid phase. But as we change the kinetic energy of the substance, what happens? You take the ice out of the freezer, what happens? It starts to liquefy. So the phase changes from a solid to a liquid, and then we have water. If we keep increasing that temperature up until 100 degrees Celsius, what happens? Your water will start to boil. So you'll start to now see above the surface of your water vapor or gas. So because we are changing the temperature, it means we are changing the kinetic energy of these particles. We are changing the kinetic energy. And if that kinetic energy is changing, it means that the phase of the substance might also start to change. So this is why with solids, you find that these particles are just moving or vibrating within their fixed position. They don't have a lot of freedom. But the moment you have a liquid, they start having a little bit more freedom, and you have these spaces in between. With gases, they're even much further apart. So the sixth point of the kinetic molecular theory is that a phase change may occur when the energy of the particles changes.